This video presents Astroprecisions instrument for reducing tilt in an astro imaging setup. The video covers both the theory and use of the instrument. So, the goal of the video is to show how tilt can be reduced in an imaging setup in minutes, inside, at your desk. But first, some theory behind the instrument. The figure shows the optical geometry of the instrument. A laser beam is projected onto the chip surface and reflects onto an imaging plane. When rotating the instrument 360 degrees, the reflected laser beam draws a circle on the imaging plane. By measuring the diameter d in millimeter, it is easy to calculate the distance epsilon, the maximum deviation from the plane surface. Note that L is the length of the diagonal of the chip. To achieve focus all over the chip, epsilon must be less than the critical focus zone, or new critical focus zone, depending on what you prefer to use as target. One must take into account that the focus zone is reduced due to curvature on the focus field of the telescope. The rest of the video will be a demonstration of how the instrument and the application is used to calibrate, or maybe the word lineup is more correct, an imaging setup. The setup includes all parts except from the telescope itself. This is the setup that I am going to calibrate in the demo. It consists of a ZWO 1600 mono, a ZWO 7-position filter wheel with one empty slot, a Gerd-Naumann camera tilting unit, a small extender, and the SpaceCat 51 tilt adjuster. As the theory described, a definition of the equipment is required to be able to compare what is measured with the critical focus zone. That is done in a profile which can be added by selecting the Add in the Profile menu. Here I am filling in the values for my setup. A unique name is required to be able to select the one to be used in the calibration. There are two more selections that must be done prior to starting the calibration. First, the created profile is selected in the Profile combo. Then, since my setup contains a filter wheel, a filter that passes the red laser beam is chosen. Red, clear, HA filter. And as in my setup, an empty position can be used. The application has now to be connected to the instrument. First, select Instrument Camera in the Camera menu. Then, since this is the first time calibration on this setup, uncheck the Use Profile Exposure so that ideal conditions are calculated. Finally, press the Connect button. The real-time view will show the red laser with a green cross in the center of the beam. The cross shall be fairly stable. If not, try to adjust the exposure length with the slider below the view until it is OK. The setup has now been completed and the calibration can start. It is done by pressing the Calibrate button. The calibration window is now shown. The window contains the result view, a result table with history, the drawing of a 3-screw tilt adjustment unit and the wizard guide text and control button. It is an advantage to orient the instrument on the Setups adjustment unit according to the adjustment unit drawing. That makes repeated adjustments easier and the given adjustment support correct. The application does not in current version have support for 4-screw units. In such a setup, sample approximately at each 120 degrees. Now it is time to follow the wizard steps. Read the text, rotate, and press the button. After 3 samples, the computed result is plotted together with circles for both critical focus zone and new critical focus zone. The legend at the top defines the color used. Additionally, the reduction in actual focus zone compared to ideal is displayed. A negative number indicates that measured tilt makes it impossible to get focus on the whole sensor. As seen here, the measured circle is just inside the new critical focus zone circle, so adjustment is required. As the wizard text indicates, it is now time for adjustment. Don't forget to rotate the instrument to the starting position. Pressing Continue gives a real-time view. The plus-minus signs on the drawing indicates the direction to turn the screws. Plus is raise, while minus is lower. Select screws to and turn until the plot marker is centered. When done, press button and start a new measurement. And of course, that is true. The result here is much better. The same procedure can now be followed to get it even better. Remember that the resolution in the result view is 5.5 microns, so when the circle becomes just a few pixels wide, it will be almost impossible to get it better. Thank you for watching. I hope you did find it interesting enough to try it out. You can order a unit at our website, and if you have any questions, please don't hesitate to contact us.